think that there's a shortcut result for that. And it's here. Well, no, not for that one. You have to do it just what, yeah, here it is, right here.
What is 16?
And if they want you to do it out, well, actually, they want to verify it. No, they want you, that's the result. They want you to prove it by doing what you did, yes. Right, unfortunately. Okay, so these are all up there, so let's check and cross-check and see if there's anything to talk about. Okay, here's one. So everybody clearly knows what we're doing. So we're ironing the wrinkles out of one. Other than that, so any questions, comments? Okay, we're on break for 10 minutes. It's now 9:08. Come back 9:18. Finish up 9:18.
You can't, there's no way.
The six actually have a silence camera. But
Yeah, I know, but here it's like,
Cause it's like they're invading someone's privacy, but taking someone's picture, they don't know.
yeah.
Because there's no sound. So
I don't know, I heard that the reason that they had the camera noise here is because like people were taking pictures of girls' like skirts.
Yeah, inside the train.
Yeah.
Because
Yeah.
I don't know why you want to take pictures of skirts when you can take pictures of algebra problems.
How old are you guys? If you guys don't mind me
18. We're all for 18.
You feel old?
She won't have the years that I do.
Shut up, you're like 8 months older than me.
But yeah, I'm 22.
It should be.
If the years were worth it, they're gold.
Is your
What? Wanna repeat that?
like no water? No, don't put it in.
yeah.
I don't know, still probably have like patience and
You could start over here for the next section. Cause I did the last 3 problems for section 6.
Well, let's see what gets up on the boards. In other words, you'd like to start in section 6 as presentation mode.
Yes.
That's not an unreasonable
With
approach.
his problems as well.
Factory,
Oh,
that's presentation mode. Hmm. That seems reasonable. So, yeah, I'll just absorb that as presentation. And so, tonight anyway is 7 and 8, so I'll just present 6, 7, and 8.
Because of this, you added,
There's a second question.
and here, how do you have
Just look what you're doing.
This money.
from here downward, I don't get it.
When?
From, no, the last two, yeah, those two, like, cause you used to subtract.
That's zero.
Yeah.
That's zero. That's zero.
So this is 0. Oh, I'm over here. See, you subtract, how come you still,
Where?
is this supposed to be negative?
Yeah, because you're subtracting. So
So
that's,
it should be 0, right? Huh? Right?
I'm confused too.
she got it right.
Or I'm like, okay, this one, you put y, right? So y times this, it's this, right? And then y times this is a minus y squared, okay? And then y, and then y, so this is plus. Okay, minus that. Okay, now we're subtracting, so we make this and make that plus, and we should make this minus, right? So this should be a minus. And then so this cancels out, it's gonna just be minus, so this should be 0. This should cancel out too, right? So this should be gone. And then this one. Or should
Oh, we put them back. Did you go into the lounge today? Oh, last time I put up how many pages that we pushed it. So it's like super expensive now. Well, we pushed it like last year, like for more bottles. So it's one time,
But it's right.
water shower in the corner. It was like, and then got too often.
Connor, hey Connor, can I see your, front page? Yeah.
I mean, I don't.
So like this step, right, this one, to get this, so y times this, right? So, yeah, so that'll be 2y cubed, and then y times this, so that'll be negative y squared. And then y times 1 will be plus y squared, right? And then when you subtract, that cancels out, and then you add this, so that's 2y plus. Yeah, and then this one just cancels out, right? Why is it negative? Oh, yeah, that cancels out. So this should be gone, right? It should just be 2y.
She always talks about drinking, and I really want to see her, like,
She's fine.
I really want to see her.
No, I'm still got y here.
How'd you get the y?
Negative 2y squared.
More.
Cause you
Oh, I
subtracted
got
y,
it.
right?
And hers, I was.
So that should cancel out.
Squared plus 1.
Wait, where's that?
You see, it says it right there.
Yeah.
So it should cancel out because you're subtracting. So it should be gone.
I didn't, how did that go?
It should be, it should be y in there. Yeah.
But
Yeah, this is like.
Congratulations, what are you doing?
she got 0.
don't think you put down the one yet, you only do one and
As,
two.
as, as tracking as meetings, but.
No put down the Y because of zero.
Maybe you don't put it down, put a zero.
So wait, you're trying to get each other?
But you
Or
said
you
the
can put,
Y.
you can put 0 Y, just,
Yeah.
just Y.
I put zero one. Oh, you put zero one.
You like the attention.
No.
Oh, I get it.
Like, we're sorry, I'm
Alicia, I got it.
Yeah, because of
Because
zero.
it's zero y.
That whole nine.
Because of
So, so when you're subtracting the y,
Yeah, it's
it'll be
because of-
negative y.
Yeah, because of
So, I got it.
Yeah, because of
Oh, yeah.
It'll be minus one.
Yeah,
Minus
Y.
y, you got it. Minus y.
Yeah, you're
Go
one.
ahead. About 2 minutes, and we resume.
That's it. Set it out.
Yeah.
That just confused me.
I mean, I don't know the difference.
Okay, so 60 seconds, and it's my turn. Does anybody want anything on the front board to stay? It's okay to erase everything. Okay, take your check. Take your time. Okay, so nice work. Good night's work. And, okay, so I'm going to present two sections, section 7 followed by section 8. And if time permits, which it probably will, I'll go back and do 6. But it's more important that I get the new stuff out there because I know you don't want to miss the opportunity to do more homework. So I'll do the new stuff first and we'll go back and do section 6 as time permits. So, chapter 7, section 7 starts on page 83, if you want to follow along, and we'll work through the examples. And the title is Solving Quadratic Equations. A quadratic equation is of the form ax squared plus bx plus c equals 0. And if it's not in this form, then very often what you do want to do is put it in this form and then look at it and see what you can do with it. But sometimes you don't. There are other strategies. If it is in this form, then one of the things that you want to do immediately with it is try to factor it into two binomials. In this case, you'll get two rational numbers by setting each one equal to 0. So this is familiar. We've done that many times. So let's take some that might be a little bit harder and explore their techniques. For example, suppose that you have a problem x squared minus 36 equals 0. Then there's no sense to put it into the standard form. You can simply say x squared equals 36 and then take the square root of both sides and then you get x equals 6. Now generally we would say x equals plus or minus 6. But until right now, our author is only taking the positive values of square roots. That's not really complete, but for the moment, that's what he's doing. So we would stay with the positive value of 6, just to go along with him. And now we can take a more complicated example of the same type, which is 2 times x plus 3/2 to the square power minus 15 over 2 equals 0. So if we can put it into a form such as this, we can take the square root on both sides. So let's try to put everything on the right side except the quantity that's being squared. And now if we divide both sides by 2, then we get x plus 3/2 squared is equal to 15 over 4. And now we can take the square root on both sides. And we get x plus 3/2 is equal to square root of 15 over the square root of 4, which is 2. So that x is equal to square root of 15 minus 3, everything over 2. So now this time he is now taking plus and minus. So he's changed himself again. He's now taking both square roots. So we will also take both plus and minus as the square roots. Okay. Next is called the method of perfect squares, and it's based on the fact that a plus b quantity squared is equal to a squared plus 2ab plus b squared. So that if you can produce this, then you can replace it with that, whereupon you can take square roots. So let's make it clearer with an example. The example given is 3x squared minus 24x plus 5 equals 0. Now, some of you are saying we can go directly to the quadratic formula and solve this, and you can. And if I'm teaching the course only for myself, I go directly to the quadratic formula, and I never teach the method of perfect squares, because you can always use a quadratic formula and get to the same place. But it's a required part of the curriculum, so we'll go about doing that right now. And we have 3x squared minus 24x, and we put the 5 on the other side. What we have here, I'll do a little side work, is 3x squared minus 24x. Now I want to put that in the form of a plus b quantity squared is equal to a squared plus 2ab plus b squared. So the first thing that we can do before we come to this part is simplify by just having an x squared in front. So let's divide everything in sight by 3 and get x squared minus 8x is equal to minus 5/3. And then we will take that over as what we want to complete the square with. X squared minus 8x. And we want to add a term to this that will cause this to be of this type. And the other one is that a minus b quantity squared is equal to a squared minus 2ab plus b squared. So we want this to be of the form x minus something squared is going to produce this. And the term that we add to it, we call this a plus bx. And we want to add a term to it, and the term that we want to add to it is b over 2a quantity squared. So let's identify what b over 2a quantity squared would be. So b is 8, and a is 1, so b squared is going to be 8 over 2, which is 4, squared becomes the 16. So if we add 16 to both sides, a 16 on that side and a 16 on this side. So we get x squared minus 8x plus 16 equals minus 5/3 plus 16. Now my rationale for adding this term, which is b over 2a squared, where this is b and this is a, is that now the left side is one of these. And what is it? It's one of these perfect squares, and which one is it? Can you work it backwards? We have x minus 8x plus 16. And it's one of these. It's either an a plus b quantity squared equals a squared plus 2ab plus b squared, or it's a minus b quantity squared equals a squared minus 2ab plus b squared. Can you look at this and can you fit it to either one of these? Okay, well, what is the square root of 16? 4. So we want x minus 4 quantity squared. Because if we square that, we get an x squared in the front, we get a plus 16 at the end. And what do we get for the middle is, clear by foiling it if you want. So you get an x squared minus 4x plus 16, x squared minus 16 minus 8x plus 16. Okay. So this is equivalent to that. And we forced it to be equivalent by adding the right thing that would complete the square. If we add a 16 to x squared minus 8x, then we have formed a perfect square. So you want to add the right number to the left side so that it becomes a perfect square. And that right number is minus b is b over 2a, quantity squared. So it's a technique. So I'm showing you this out of a requirement. It's not a method I recommend. So this becomes x minus 4, quantity squared, is equal to minus 5/3 plus 16. Now we have to take the square root of both sides. X minus 4 is equal to the square root of minus 5/3 plus 16. So now to complete this, we have to ask what is minus 5/3 plus 16? So who wants to tell us? So 16 is 48/3. So it's equal to minus 5/3 plus 48/3, which should be equal to the square root of 45/3. And this is x minus 4. So if we want to put the 4 on the other side, then we finish the problem. Now, having shown you the method of completing the square, then we will show you that the problem can be done much more easily. So this becomes, this is a plus or minus, by the way, because we're taking the square root. So this becomes 4 plus or minus the square root of 45 over 3. Now I'm going to show you that completing the square can always be done by using the quadratic formula, and that's much more simple. So let's take the original problem. Yes,
Should it
ma'am.
might be 43 with it?
43, it should be a 43, thanks. 43. I know that looked like a 5 from back there. Okay. So minus 5/3 plus 48/3 becomes 43. How come you didn't fix it? Are you just being polite? Okay, so let's look at the original problem. 3x squared minus 24x plus 5 equals 0. The general form, ax squared plus bx plus c equals 0. So our quadratic formula, minus b plus or minus square root b squared minus 4ac all over 2a. Parameter is a equals 3, b equals minus 24, and c equals 5. Substitution, x equals minus a minus 24 plus a minus 24 squared minus 4 times 3 times 5 all over 2 times 3. So x equals plus 24 plus or minus, and somebody please tell me what is 24 squared? 576. 576 minus 12 times 5, which is 60 over 6. So it equals 24 plus or minus the square root of 516 over 6. And 516 is subject to reduction. By one of our perfect squares, and our perfect squares are 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144. So let's see if one of these will divide into 516. How about 36? Does 36 divide into 516? No. Does 64? Well, I'm sure 4 does. 4 is, yeah, 4 goes into it, true. So I'm going to do some side work, and I'm going to reduce the square root of 516. So it's equal to the square root of 4 times 124? 129. And so that's equal to 2 times the square root of 129. And 129 will divide by 3, not necessarily a help. So can we reduce 129 further down by a perfect square? 9? No. 129 reduced further? Well, we'll go over there as a 43, don't we? So it should reduce by 43, and it does. 129 is equal to 43 times 3. So it's equal to 2 times, I don't know that helps, because none of those is really going to simplify it. So yeah, that comes out the same over there. Yeah, it comes out the same over there when you put it over 3. So we'll just keep working with it. So this becomes equal to 24 plus or minus the square, plus or minus 2 times the square root of 43 and the square root of 3 all over 6. Now we can divide top and bottom by 2, and we're going to get 12 plus or minus the square root of 3, square root of 43, and that is going to be over a 3. And if we divide the 3 into both pieces of the top, we're going to get 4 plus or minus the square root of 3 over 3, square root of 43, and the square root of 3 over 3 is the square root of 43 over the square root of 3. So we end up with the same answer going by quadratic formula or going by completing the square. So you have your choice. The one that's more friendly to you is the one that you go. So these are 2 main methods of solving quadratic equations. One, you simply take square roots of both sides. 2, you use a quadratic formula. Or if you happen to like completing the square, then you can go about that method. So these are our main methods for solving quadratic formulas. And now I want want to illustrate a more advanced type, W fourth plus 3W squared minus 1. W fourth minus 3W squared plus 1 equals 0. And let me check the signs on that. Okay, we have a winner. Now, you are going to say foul. You didn't want to see this because I'm promising you we're going to solve quadratic equations, which are of power 2, agreed? So I'm out of bounds to produce a power 4 equation. But you recognize from the form of it that we can do this by substitution. We can form a substitution. We can say that u, a new variable we produce ourselves, is equal to w squared. We define u to be equal to w squared. If that's true, then what is u squared equal to? W to the fourth. So let's make these substitutions. This becomes u squared minus 3u plus 1 equals 0, and it's a quadratic equation as I promised. So by making a definition of our own and substituting it in, and we were able to recognize that because we had a fourth power and a squared power. So it jumps right out at you that you can make this substitution. So your first task is, will this factor? This will not factor, so you have to use quadratic equation. U is equal to minus b plus or minus square root of b squared minus 4ac all over 2a. And a is equal to 1, b equals minus 3, c equals 1. So substitution, minus and minus 3 plus or minus 9 minus 4 times 1 times 1 all over 2. Okay? So it is equal to 3 plus or minus square root of 5 over 2 is what u is equal to. But we weren't interested in what u was equal to. We were interested in what w was equal to, agreed? So because we found u by a process of substitution, we have to find w by a process of back substitution. So remember our definition is that u is equal to w squared, agreed? So now we have u is equal to 3 plus or minus square root of 5 over 2, and that's equal to w squared. So how do we find w if this is w squared? Simple, you take the square root of both sides, agreed? So you now have a square root and a square root. So welcome to Math 107. You don't really have that in the lower courses. So w is equal to plus or minus the square root of 3 plus or minus the square root of 5 over 2. So you end up with a square root within a square root. A little complicated.
And is that the final answer?
It's a final answer pending a brilliant simplification by someone other than myself, because I see no further simplification. So if you do, please go there. But I don't happen to see any further simplification. So therefore, I leave it at that. Absolutely. So let's see if there's another type. There is another type, and it involves two square roots, and I'm not sure if he goes there himself. I think he does. Okay, I'll postpone that for the moment, and we can certainly do it if we find one. And I want to say a few words about this item right here that I'm about to draw a box around. That quantity, b squared minus 4ac, can tell you what type of solutions you're going to find. For example, if this turns out to be a perfect square, say 49, then that means that you're going to be taking the square root of 49, which is a 7, is it not? That means that the radical sign has disappeared. And that means that there are no irrational roots. That all of your roots are going to be expressed as fractions. So if this quantity turns out to be a perfect square, it means that the original quadratic equation was factorable and you missed it. It's called embarrassment time. It means you could have factored the original equation, but you either didn't bother or you missed it. Some people go directly to the quadratic equation for all second-order equations. They don't even try to factor it, because the quadratic formula will handle those which could factor. But if it could have been factored, then the radical sign will contain a perfect square. So that's case one. Now this expression, b squared minus 4ac, is called the discriminant, because it discriminates between the various types of answers that you could get. And the first type is when the discriminant is a perfect square. It means that your two answers will be rational fractions, and you could have discovered them by simply factoring the quadratic equation. The second case is that if this turns out to be 0, if this turns out to be 0, then it's not here. And if it's not there anymore, the plus and minus are missing, aren't they? And there's only one answer left. There's not two answers, because it's the plus and minus that generated the two answers. If you take this away, how many answers are left? One. So this is a quadratic equation that has only one answer. But quadratic equations are required by law to have two answers. So the way we express this is that the solution to this equation, for example, would be 3/2 with a multiplicity of 2. It's a double answer. And that's a formal requirement in algebra, that a second-order equation must have two solutions. So if you find that it collapses to one solution, then you would say that u equals 3/2, comma, 3/2. You count it twice. And that's necessary for the other aspects of algebra, that you go ahead and do that. And the other thing that the discriminant can reveal to you is if this discriminant is less than 0, if this discriminant turns out to be negative, for example, a minus 49, can you take the square root of a minus number? No. You can improve it into an imaginary number, but it has no real square root. So that means that this equation has no real solutions. It has solutions that involve the square root of -1, but they are not real solutions. And we're going to spend quite a bit more time on that in this course, what we mean by that, okay? If that discriminant is less than 0, it means that this quadratic equation is going to have a minus square root that you're attempting to take, and we don't have any minus square roots in our number system. So that means all of the roots are just imaginary. They're not real. So that's the information that the discriminant can tell you. Okay, so let's go forward to the next section, which is one that's not entirely popular, and it's called simplifying a rational expression. And even worse, to solve an equation that has rational expressions in it. Now, the use of the word rational here is the same as the use of the word rational and rational number. What is a rational number? It's one integer over another. So a rational number might be 2/3. And a rational expression is one expression over another. And just as with a rational number, if you get a rational expression, then your job is to simplify it as much as possible. If you have a rational number, say 12/16, can you reduce it? By 4, agreed? So if I give you a rational expression, then I want you to tell me if you can reduce it. So let's get a good one right away. X to the 4th minus 5x cubed over x to the 3rd minus 25x. Now on the face of it, it doesn't look like you can reduce it. But just as with 12/16, what we do is we break each number into its factors, like 3 times 4 and 4 times 4. And we look for common factors that we can cancel. And in this case, we find that these can be canceled, agreed? You take the same approach here. You break each numerator and denominator into as many factors as you can. And then you see if you have any common factors that you can cancel. So on the top, is there anything we can cancel, factor out? X cubed, and we get x minus 5 left, agreed? In the bottom, is there anything we can factor out? X, and we get x squared minus 25. So now we can cancel one x with the x squared, agreed? So we have an x squared on top, x minus 5. And in the bottom, we can factor x squared minus 25 into x plus 5 and x minus 5. So let's do that. X plus 5 and x minus 5. And now do we find any other factors that can cancel? And we end up with x squared over x plus 5 as our simplified answers. So you follow the same procedure of breaking numerator and denominator into as many factors as you can and canceling anything that's present in both the top and the bottom. So the author's making a real point out of a possible problem. I don't think anyone in here would do this, but he's worried. So let me ask you. He is worried that you might take x squared plus 9 over 5 and break it into x, no, that one's okay, so he's worried about the other one. He's worried that you have 5 over x squared plus 9, and that you would break it into 5 over x squared plus 5 over 9. No, agreed? No one would even think of doing that, true? No, that's not what you do. But if you have x squared plus 9 over 5, is that legitimate to go x squared over 5 plus 9 over 5? Absolutely, that is a legitimate step, true? It breaks apart that way. So it doesn't want you to make that mistake. Now we get into a worthwhile, complicated one. So let's take it through the steps. 2x squared minus 5x minus 3 over x4 minus 4 times, divided by x squared minus 2x minus 3 over x to the 5th plus 2x cubed. First, let's change division into multiplication. What do we do to do that? Reciprocate, okay. 2x squared minus 5x minus 3 over x4 minus 4 times x5 plus 2x cubed over x squared minus 2x minus 3. Now, we factor everything in sight. 2x sideward. See if these will factor. So 2x squared minus 5x minus 3 factors into what? Okay, do I win? I win. Okay, so we can make that replacement. 2x plus 1 times x minus 3. Let's go to the bottom. X to the 4 minus 4. Does that factor into what? X squared minus 2 and x squared plus 2. Agreed? That's the difference of perfect squares. So x squared plus 2 and x squared minus 2. Now, we have here, we can pull out an x to the 5th, x to the 3rd, agreed? And what's left if we pull out an x to the 3rd? X squared plus 2. Isn't that nice? Because we're going to have a cancellation down here. Now some more side work. X squared minus 2x minus 3, will that FOIL, factor out? X and an x minus 3 and plus 1. Do we have a winner? So x plus 1. So you factor everything in sight, and then you look for cancellations. So do we find any? We find this cancels, that cancels, this cancels, this cancels, and I don't see any others myself. So we have come to a grinding stop. 2x plus 1 over x cubed over x squared minus 2 over x plus 1. Now some of you, when you looked at the original problem, you immediately said, well, the answer is 2x plus 1 over times x cubed over x squared minus 2x plus 1. But as human beings, we have to go through the factorization and the cancellation to see what actually disappears. So that's a typical type of problem is what we'll do. And now it gets worse when you set these into an equation. So let's see if we can use our time judiciously. It was mentioned at the beginning of tonight that these negative powers cause a little trouble. So let's see what we can do with those. Example. We have a simplification to make. 2t to the minus 3 minus 3t to the minus 2. Okay, so what's our first step with these minus powers? Right, so we remember that in general, a to the minus n is equal to 1 over what? A to the minus n is equal to 1 over a to the plus n, agreed? So we can change these right away. This is 2 over t cubed minus 1 over 3t quantity squared. So we can go about the squaring it. We had 2 over t cubed minus 1 over 9t squared. Now we're gonna look for a common denominator. So what is that common denominator? 9
Nine,
times t,
90.
9t cubed. So if we have a t cubed at the bottom, the 9 is missing, so we get a 2 times 9 here. And we have a 9t squared, the t is missing, so it's a t. So we get 18 minus t over 9t cubed for our simplified answer. So we can do those. Well, here's a nasty problem that doesn't look like it would be nasty. So let me just have you guys do this one, not me at all. 1 plus 1 over x equals x. Okay, so everybody go. Let's have you all do that one. So Kayla, you have an answer.
Oh.
Oh. Megan, you got yours? Okay. Anybody have a first step? What would you do, Jared, for your first step?
Find the common denominator.
That works. And what is that common denominator?
X.
Okay, now you found it, what are you gonna do with it?
We add both functions.
Oh, in other words, you're just going to combine the terms on the left side.
Yes.
Okay, that's valid. So this is going to be x plus 1 over x equals x. So we combine the two terms on the left. Okay. So then what would be your next step? No, because I didn't multiply anything. I just combined two fractions into one. I would have done that, but he has a different style. So all he did was combine these two fractions. These two fractions are equal to this fraction. So he didn't touch the right side. He just combined those two, which is a style. And now what would your next step be in this style?
Multiply both sides by x.
Yeah, multiply both sides by x. And that is done to both sides, so x plus 1 is equal to x squared. Now you've gotten rid of the fraction, which was your first attempt. And now that's a doable problem. So that one you can do by the method of your choice. Well, I write the monster on the board. just finished this problem on the right side by a method of your choice. Alicia, do you have a solution for this one? Okay. Now, generally, what's our best strategy if we have a quadratic equation? Best strategy is to put it in standard form and try for the quadratic formula. So how would this be in standard form? So we put it in standard form now. And now we make our parameter list. A equals 1, B equals -1, C equals -1, and we use the quadratic formula. Generate our answer. So Connie, you have your answer already. What you have?
1 plus minus square root of 5 over 2.
1 plus or minus the square root of 5 over 2. Okay. So, let me double check that there's compliance with that. It's all over 2. It was just a matter of listening. 1 plus or minus the square root of 5 all over 2. And we have that simple answer. Now, this monster on the left board is for you to do. Solve for x. Who's done? Solve this one for x. This is not an introductory course. This is a university level college algebra course.
What's the equal?
So that
Equals 0. Many steps. This could have been a go home problem, but I don't want to sleep with it. Many steps. get worse instead of better, Megan? You got an answer? Showstopper. Josh? That's a good homework problem, too easy for a test. Well, it's good for homework. Connie, you got it? Anyone like to see Conan work through? Conan, they'd like to see how you got it too, which is the correct answer. I mean, just looking at it, it's obviously a two, isn't it? What else could it be? So let's come up and show some steps. Very nice work on a non-trivial problem. So you want to start over there, and if you need more boards, we'll just erase some. So,
The top minus. The 3 over x squared plus 4 minus, no, up, another one. Yeah.
Here?
Is it that minus sign, yeah. Is it a minus?
so. So let's go to something more human. 6. And this is a much more human problem that I'll put on the board now. And we just want to factor this one to as far as possible. Now, when we factor, we have a couple of identities that are useful to us. A plus B quantity squared. Kyla, do you know what A plus B quantity squared expands into?
A squared is 2AB plus 2AB plus B squared.
Good. And then A minus B is the same thing with a minus sign in the middle, A squared, and this is useful too. And then A cubed minus B cubed expands into A minus B times A squared plus AB plus B squared. And A cubed plus B cubed expands into A plus B times A squared minus AB plus B squared. So those are identities that you can write down on a piece of paper. They're in your book, and they're useful to you, and you should, of course, at some point know them. So 18x squared minus 48x plus 32. The instructions are to factor this. Now, what's the first rule of factoring, always? First rule of factoring. Okay, I'll say it once, is to pull out common factors. Pull common factors out. So is there anything common to pull out?
Maybe a 2.
At least a 2, agreed? So we get a 2, and what we have left is 9x squared minus 24x plus 16. Now look at your list of helpers over there, and do you see anything that is going to apply here? You ask the question, is this a perfect square?
Yes.
Is this a perfect square? Therefore, it just might be one of those. If this is a perfect square, then what's its square root? The square root would be 3x, wouldn't it? Now, if this is a perfect square, what's its square root? 4. So now we've covered the two endpoints. The question is, are they going to combine to give the correct middle? And first, do we want a plus or a minus? We have to have the minus. So now you ask, do they produce the correct term in the middle? And indeed, this did turn out to be a perfect square. So we have reduced it down. So the next type of problem is like this, x to the 6 minus 64. Our job is to factor this down. Once again, look in your list of help and see if you see anything that might help. Is that a difference of perfect cubes? Is x to the 6th a perfect cube? I think that x to the 6th is equal to x squared cubed. Is that not true? So x to the 6th is a perfect cube. Is 64 a perfect cube?
Yes, 4.
4. Oh, so this is equal to x squared cubed minus 4 cubed. So once we write that, we can use our helping formula, agree? We know what the difference of cubes is, and the formula is that a cubed minus b cubed equals a minus b times a squared plus ab minus b squared. Now in this case, what is a going to be and what is b going to be?
Squared and 4.
A is x squared, is it not? A is x squared, and b is 4. So this becomes x squared minus 4, and what we have then is a squared. So what does a squared become? If a is x squared, then what does a squared become? X to the 4th, plus a times b, which is 4x squared, this is a plus typo here, plus b squared, which becomes 16, agreed? Okay, now, are we done? Are we done? Josh, are we done? Or is there one more factorization that can take place? Is there one more factorization that can take place? And the first one, x squared minus 4.
Oh, X squared.
Right. Oh, we have one more helper over here, that an a plus b times a minus b is equal to what? Who remembers? Connie, remember what that's equal to? A squared minus b squared. Now, here, do we have an a squared minus b squared? We do have an a squared minus b squared, so what would that break down into? X plus 2 and x minus 2. And this over here is prime, it's not going to go anywhere. So we've reduced that by recognizing it was a difference of perfect cubes, and we have just one more to take care of.
Can't you still reduce this one?
I'm not able to reduce that. If you are, then want to, oh, actually, Deb, I want to hear about it, because I'm not able to reduce that any farther.
Oh, yeah, no.
No, I got stuck on it, so that's as far as I could get. So I think we find one more, and this is be the last one that we do, and it is worthy of a go home, because we have to clear denominators. Now, Jarrett likes to clear denominators by combining them. Alicia likes to do it by clearing fractions. I also recommend the clearing fractions technique, so I will follow that one here. We have w to the 4th over 3 equals 8 w cubed minus 12 all over 12 minus w squared minus 4 over 4. Now, in this equation, I see three denominators. And what are they? 3, 12, and 4. And what's the least common multiple of 3, 12, and 4? 12. So if you multiply everything in sight by 12, it's a good algebraic step, because you are doing the same thing to both sides. So it's a valid step. But if you do that, then you observe what Alicia has known since first grade, and that is that all the denominators disappear, which is the motive for doing it. So the 3 goes into the 12 4 times. You get 4w to the 4th. These two 12s cancel out, equals 8w cubed minus 12. And this 4 goes into the 12 3 times, so it's minus 3w squared minus 4. So I've cleared the fractions for you, so I'm going to leave the rest up to you guys. So now you go ahead and work through the remainder of this problem, which has a smell to it that is going to be done by factoring, by grouping. But I can't verify that, but it does look like one of those. Actually, I think it can be done by grouping. It can also be done by simply factoring. So however you do it. No, it might not be able to be done any other way. So let's see how you all do on this one. On trivial. So clearly, first we're going to collect everything on one side and combine like terms. standard operating procedure. And after doing that, you should end up with 0 equals 8w cubed minus 3w squared minus 4w to the fourth. So please confirm that after putting everything on the same side and combining like terms, that you got there. Okay? So Megan, did you get there, to that point? Okay. So now, we got to continue factoring, and once again, what's the first rule of factoring? Take out, first rule of factoring is to pull out common terms, agree? So Megan, what's common? What's common to the three terms?